Hi, this is Mr. Frazier, and again, we're going to try to do 5.3a and 5.3b concerning perpendicular bisectors and angle bisectors. Alright, so let's start with the word concurrent. Hopefully we understand that concurrent means where more than 3 lines touch. So 3 or more lines are called concurrent when they touch at the same spot. Okay, so concurrent means 3 or more lines touching at the same spot. So here I draw 3 lines, and remember our lines have arrows. So we have 3 lines, and here's the third one. Now, what you should have noticed is that after I drew 2, once I knew where 2 of them were touching, obviously if I draw a third one and it's supposed to touch, it's going to touch in the same spot. So when they say things are concurrent, that means once you draw 2 of them that are touching, the third one must also touch in the same spot that the first 2 did, because lines only connect in one spot, or intersect, as we say. Now you could draw segments that are concurrent as well, okay? And segments just wouldn't have the arrows, but it's the same concept. There's 3 of them. They're called concurrent. So when your lines don't touch,
who is not with a coach or a sponsor need to leave the building immediately.
okay, so
Again, any student that is not with a coach
I will continue
or a
talking.
sponsor
So
leave
any
the building
lines that
immediately.
touch at the same spot are called concurrent. Okay, if it's just 2, they're intersecting, but when it's 3 or more, they're called concurrent lines. So if they say you have concurrent lines, that means you have at least 3. If they tell you that they're intersecting, there's only 2. All right. Where they meet, where the concurrent lines meet, is called the point of concurrency. So the point at which they all meet is called the point of concurrency. And remember, points are labeled with capital letters. So point A would be the point of concurrency. Point C would be the point of concurrency. It's understanding what the point of concurrency is. And we have several different types of points of concurrency. The one we're going to talk about right now is called the circumcenter. So, here we are. Circumcenter. Okay, Mr. Frazier, what is the circumcenter? Well, it's where all certain types of lines meet. All of these have to do with certain types of lines. Now remember, this is memorization. The first type of line we're going to talk about are perpendicular bisectors. So hopefully you remember that perpendicular means they're like this, and bisectors mean they're like this. So that would be one perpendicular bisector. In a triangle, you can have 3 perpendicular bisectors. Why? Because it has 3 sides. Notice, that's what it has to look like. Now, already I know where my point of concurrency is, because if the 2 points have to meet here, guess where the third one has to meet? In the same spot. And there you are. There are 3 perpendicular bisectors, and this is the point of concurrency. Okay? So, being able to identify what you're starting with. Hey, these are all perpendicular bisectors. That's a point of concurrency. It's called the circumcenter. So the circumcenter is where all your perpendicular bisectors meet. Okay, so where all your perpendicular bisectors meet is called the circumcenter. It's only perpendicular bisectors. So you have to know that these are all perpendicular bisectors. So when you look at the picture, hey, those are perpendicular bisectors. Now that's the definition. Okay? Now there's a rule that goes with the circumcenter as well. Now that rule has to deal with the circumcenter. That means when you have a circumcenter, it is equidistant to the angles or vertices. So the circumcenter is always the same distance to the corners. Now, you're going to have to probably follow this logic. If the perpendicular bisectors come from the side, then the equal distances are to the corners. Just like when we talk about angle bisectors, excuse me, that if you have angle bisectors, they're coming from the angles, so the same distance would be to the sides. They're reverse of each other, because perpendicular bisectors bisect the sides. Angle bisectors obviously bisect the angles. So I'll repeat this again with the next picture. This is an acute triangle. And in an acute triangle, your circumcenter will always be in the triangle. With an obtuse triangle, your perpendicular bisectors will always meet out of the triangle. Here's my last perpendicular bisector. And again, once you saw two of them meet, you knew the third one had to meet in the same spot. Now I continue this line up, but notice they meet outside. So that means this is the circumcenter, and this circumcenter is the same distant or equidistant to all of the vertices. It's kind of like a teepee or a hut. Okay? Those are all the corners, and you can kind of see it look like a teepee. But all the perpendicular bisectors meet at the circumcenter. And that circumcenter, the rule is the circumcenter is the same distance to all the corners. So that means you could put these two things equal to each other. You could put these two things equal to each other. You could put all three of them equal to each other. They're all equidistant. Now, why is this important? Well, this is important because you have to match pictures. When you're looking at something, it should make sense. In a right triangle, so our first rule was the perpendicular bisector in an acute is in. All the perpendicular bisectors meet inside the triangle. For an obtuse, they meet outside. So where do you think they're going to meet for a right triangle? You got it. They're going to meet on the hypotenuse. Okay, and then I would do this. And here's my circumcenter. And you can kind of see when I do it, even though I'm rough drafting it, hey look, I cut it right in half. Okay, that's how I know they're all perpendicular bisectors, because they're going to meet at the same point on the right, on the hypotenuse, right across from the right angle. Does it do anything to the angles? Nope. These are all perpendicular bisectors. Why? Because they're bisecting the sides. So when you look at the picture, you have to identify the difference between bisected sides and bisected angles. This one is bisected sides. And this point is the same distance to here as it is to here as it is to here. Okay? It's the same distance to all of the corners. So in essence, in a right triangle, this distance are already marked the same, which means this distance is also the same. Okay? So this would be a right triangle. So the big key again is acute, obtuse, and right. Acute meets in, an obtuse meets out, and a right meets right on the hypotenuse. And the nice thing about this is that the circumcenter, that point where they all meet, is equidistant to the angles. So the perpendicular bisectors of the sides will all meet at the center, circumcenter, and that point is the same distance to all of the corners. So if you have a map, or if you are building something and you're trying to make sure that three things are the same distance from a fourth thing, you go ahead and put those three things in a triangle, and then when you find the perpendicular bisectors, then you could find the distance to the corners, those three things you're looking for. This is why drawing out your picture is really important. So as I said, you have the mall, you have Chick-fil-A, and you have Countryside High School. And you need to be the same distance from all of them. So you would do the mall, Chick-fil-A, and Countryside High School. If you found the perpendicular bisector of each sides, and in actuality you only need to find the perpendicular bisector of two of the sides. So let's say if you went here and you went here, that you found the midpoint between the mall and Chick-fil-A, and you found the midpoint of the mall and Countryside High School, that if you were to draw a line perpendicularly from that midpoint, where you'd meet would be the circumcenter, and that point would be equidistant to all three things. You'd be able to get to all three things in the same amount of time. Right? And this is used as a practice problem. I can guarantee you'll see this as a problem in homework as well as on a test. All right, so we've talked about perpendicular bisectors. The next thing we need to talk about are angle bisectors. What makes them different? They're bisecting angles, which means the congruency marks will be in your angles. Okay, and then once again, if you have two of these meet, you automatically know where the third one has to meet. It has to meet there. So if you have two of them, you really don't need the third, but you can draw the third. Okay, you don't need it because it's meeting at the same place. This is now called a what? You are correct. That is a point of concurrency, but it has a specific name. That point of concurrency is called the incenter. And the incenter is where all your angle bisectors meet. Now remember, all of this stuff is review because we went over it at the beginning of the year. I'm going over it again just to refresh your memory. Okay? And it's a practice of this flipping the classroom. So you have angle bisectors. Where all the angle bisectors meet, it's the incenter. Okay? Now, the nice thing about the incenter is it's always in the triangle. Doesn't matter whether it's acute, obtuse, or right. It's always in the triangle. So the incenter is always in the triangle, which is nice. But here's the key. What is the rule for an incenter? Well, it would be the opposite of the rule for a circumcenter. Why? Because the circumcenter is talking about all the perpendicular bisectors, which means all the sides are being bisected, so the distance to the angles are equal. Here, all the angles are being bisected, so you got it. The perpendicular distance, now notice the difference, the perpendicular distance, whereas with a perpendicular bisector, it's just the distance is equal to the angles. In angle bisectors, it's the perpendicular distance is equal to the sides. That means starting here and going at a right angle, this one happens to be a right angle, and this one is pretty close. All three of those would be the same measurement. But it's the perpendicular distance, not just any distance from that point to the side, the perpendicular distance from that point to the side is the same. They are perpendicularly equidistant. All right, so let's look at the obtuse. There's bisected. I'm just winging this. There's bisected. Okay. And of course, we already know the third one's got a touch there. This is bisected. Notice the congruency marks are the most important part of any picture. And again, this point is in the triangle. And the rule is, where all the angle bisectors meet, they are equidistant to the sides. Okay, and the same thing for here. I'm trying to draw these as accurate as possible. Here is our incenter. And the incenter is perpendicularly equidistant to the sides. Okay, let me move that up a little bit. Perpendicular, equidistant. Okay, so if you have angle bisectors, then you should have a picture that looks something like this. If you have perpendicular bisectors, you should have something that looks like this. So it's important that you understand what your picture is supposed to look like, because as they give you things to draw, they're trying to lead you in a direction. So let's say they say, oh, here's 3 things, and they tell you that the water fountain is all of those points. Well, which one are they talking about? They're saying all of these are places in the mall. And they say the water fountain is the same distance from all of these. So are they talking about a circumcenter or an incenter? Correct. They're talking about a circumcenter, because the same distance to each of the corners, you should see that makes a triangle, happens with perpendicular bisectors. So that means if I were to find the midpoint of each side and then draw perpendicular lines, the point where they all meet is the same distance to each one of those corners. Excuse me, a lot of talking, a lot of coughing. Apologize. All right. So hopefully we're good. If you have any questions, write them down, save them for tomorrow, ask me before we start, and you'll start on your work when you come into class. All right, have a good night. Thank you.